Hello, and welcome to ShipU Stats. In this video, we're going to look at a two-way between subjects ANOVA in JASP. A two-way between subjects ANOVA will allow us to compare independent groups that are classified by two independent variables, or examine two independent variables and their potential interaction with each other at the same time. A two-way between subjects ANOVA will allow us to examine the influence of two independent variables on an outcome variable or dependent variable at the same time. The influence of these two independent variables will each be referred to as a main effect of those independent variables. A two-way between subjects ANOVA will also allow us to examine the interaction of both of these independent variables at the same time on the outcome variable. This will be referred to as the effect of the interaction, or the interaction term. Some examples of this could be looking at both gender and college class on the amount of alcohol someone consumes, or beer specifically, on a weekday. Or does participating in athletics, as well as gender, impact the amount of beer someone consumes on the weekend? In both of these examples, we're looking at two independent variables at the same time and how they impact those dependent variables. We can also see if there's any kind of interaction between these two independent variables on the outcome variable. Like all statistical analyses, two-way between subjects ANOVAs have some assumptions that need to be met for a two-way between subjects ANOVA to be appropriate. The first is that we're comparing groups created by two independent variables. Note that the term two-way ANOVA is referring to the two independent variables present in the ANOVA. All of the instructions that we're going over today could apply to a situation with 3, 4, 5, or more independent variables. However, the interpretation of the results would be far more complicated. The other assumptions related to a two-way between subjects ANOVA are that the dependent variable is interval or ratio scale. The data is approximately normally distributed. The groups have equal variances. There are no significant outliers in the data set, and each group is independently sampled. To set up our data for a two-way between subjects ANOVA, we'll have to enter our data so that our independent variables are each represented by a column. For our first example, we were looking at class and gender on the amount of beer someone consumes on a weekday. So we entered a variable called class, and we entered numbers for the freshmen, sophomores, juniors, and seniors. For our other variable, we have gender, and so we entered 1s and 2s for men and women, respectively. We then entered a third column for all of our dependent variable scores, or the amount of beer someone consumed on a weekday. For our other example, we already have our gender variable. We entered another variable for athletes, whether or not they participated in athletics or not, and the amount of beer they consumed on a weekend. All right, let's go overhead to JASP. Now that we have our data in JASP, we can go ahead and run our ANOVA. However, before we do that, we should make sure our variables are appropriately labeled. Our dependent variables should be listed as scale variables, and our independent variables should either be nominal or ordinal, depending on whether or not they are nominal or ordinal. Once we've done that, we can go ahead and click on ANOVA, and then click on ANOVA. When we do that, we'll come to this panel here. The first thing we should do is move over our dependent variable to our dependent variable box. In this case, the amount of beer someone consumes on a weekday. And then we'll move over our independent variables over to the fixed factors box. Once we've moved both of those over, we'll end up with this ANOVA table over here. You'll notice that we have 3 different F values. That's because we're looking at the effect of class, the effect of gender, and the interaction between those two variables. In this case, all 3 of our values are significant, and so we can go ahead and conduct additional analyses. When conducting additional analyses, the first thing we should do is click on Descriptive Statistics to get our means and standard deviations for all the possible groups on our ANOVA. From here, we can go ahead and click on post hoc analyses, and we can move over our variables and our interaction. In this situation, I'm not going to move over gender because I don't need to, because I only have 2 levels of that particular independent variable. If there's a difference here, all I need to know is the means and standard deviations of those 2 groups to figure out exactly what that difference looks like, because I already know it's statistically significant. Here I can look at my post hoc comparisons to see the differences between the different classes. And I find that there's a difference between the freshmen and seniors classes, but there's not any other differences. I can also look down here to see all of the individual differences between all of the individual different groups here. And you'll notice that there's not a lot of statistical differences between these groups once we've applied the Tukey's correction. We do see a statistically significant difference between sophomore males and freshman females. We also see one between our senior males and our freshman female. And we see one between our junior males and our senior males. To further examine our interaction, we can go ahead and click on descriptive plots. And we can move over our independent variables over to these spots over here. It doesn't really matter which one you put in which, but I like to put the variable that has more levels in the horizontal axis and the other variable into separate lines. I find that this makes interpretation of the differences a little bit easier. I now have a graph that explains the relationship and any potential interactions between these 2 variables. The last thing I can do is click on marginal means to find the means of our individual groups. Specifically, this will show us the marginal means between all of the different classes and all of the different genders across just one independent variable at a time. You will notice that this particular table only shows us our means and doesn't show us our standard deviations. It does show us our standard errors, which is totally acceptable to report. However, if you do want to report your standard deviation, you can go ahead and use the descriptive split file function, which you can learn about in video 141. All right, let's go ahead and move over to our other example. In our second example, we'll be looking at beer consumption on the weekend as our dependent variable, and participation in athletics and gender as our independent variables. Once we've moved those over, we'll have our ANOVA table over here, and in this particular situation, we only have one significant F value, and that's the F value for our interaction. This means that we won't be looking at individual differences between whether or not someone participates in athletics or in gender, but we will be looking for individual differences amongst both of them at the same time, or the interaction between those 2 variables. To do this, we'll go ahead and click on descriptive statistics to see our means and standard deviations for all of our groups. And then we'll click on post hoc tests and just move over our interaction term. When we do that, we'll end up with one table that will tell us the differences between all of our different possible combination of groups. In this particular situation, we do not have any significant differences between any of our groups once we've applied a Tukey's correction. This isn't a particularly common result, but it is a result that can happen in any ANOVA. Just because we have a significant ANOVA doesn't mean that the follow-up tests will be significant. Because we don't actually have any differences, conducting a plot doesn't make sense, but if it was significant, it would look something like this. Here we have a different relationship between those who are participating in athletics and whether or not they're men or women on how much beer they consume. All right, now that we have all of our results, let's go ahead and write these up in APA format. In our first example, we had a significant F value for all 3 of our effects: class, gender, and the interaction between class and gender. To write this up in APA format, I wrote a sentence to convey that information. A two-way between subjects ANOVA showed a significant main effect of class, a significant main effect of gender, and a significant interaction between class and gender on weekday beer consumption. For each of these different effects, I conveyed the relevant information: the degrees of freedom between and within, the F value, and the p-value. Because I had significant results here, I now have to convey to the reader information about what exactly those differences look like. So here, specifically, women drank significantly more on weekdays than men. Freshmen drank significantly more than seniors. And the interaction between these variables looks to show that junior men and freshman women drank significantly more beer on weekdays than senior men. Additionally, sophomore men drank significantly less beer on weekdays than freshman women. For each of those differences, I provided the means and standard deviations so that the reader has all the relevant information. In our second example, we didn't find significant f-values for either of our main effects, the effect of athletics or the effect of gender on weekend beer consumption. However, we did find a significant f-value for the interaction between athletics and gender. To convey this to the reader, I wrote a sentence as follows. A two-way between subjects ANOVA showed no main effect of athletic participation, no main effect of gender, but did find a significant interaction between athletic participation and gender on weekend beer consumption. I then filled in the relevant statistics, degrees of freedom between, within, the f-value, and the p-value for all three of the effects. Because we had a significant interaction, we conducted some post-hoc tests between all of the possible groups for that interaction. In this situation, we didn't actually find anything. Some things were close, but we didn't actually find any significant results. So to convey this to the reader, I said, however, after post-hoc Tukey's analyses were conducted, there was no significant differences between groups. I've now conveyed all of the relevant information about this interaction, or lack of interaction, to the reader. Alright, thanks for watching this video on a two-way between subjects ANOVA in JASP.